Hi, lovely people. Welcome to my YouTube channel, Rich Brain. In this video, we are going to find solution to the problem on the board, which says that find a general solution to the differential equation x square y prime prime plus 3xy prime plus 4y equal to 0. So come along as we find solution to this problem. So remember, anytime we are faced with a differential equation, we need to find out which kind of differential equation is this. So this is a cauchy-Euler differential equation and homogeneous for that matter. It is homogeneous because it's equated to 0. And it is cauchy-Euler because the derivative are having variable coefficients. So anytime we are faced with such differential equations, we let the dependent variable y to be equal to x exponent m, where m is constant. Now, in solving this, we will be confronted with three different situations. That's when we get the value of m to be two distinct roots. Then when we get the value of m to be a repeated root. And when we get the value of m to be complex root system. And we said that when the value of m are two distinct roots, then our general solution y of x will be equal to c1 x exponent m1 plus c2 x exponent m2, where c1 and c2 are constant. And when m is a repeated root, then our general solution is giving us y of x equal to c1 x exponent m plus c2 x exponent m, then ln x. If we are faced with a complex root system, then our general solution will be y of x equal to x exponent alpha times cos beta ln x plus I sine beta ln x, where alpha is a real part of the complex system and beta is a coefficient of the complex parts. I hope you get that. Please, I have a video covering where we have two distinct roots, then where we have two repeated roots, and I will indulge you to check it out on YouTube. So today, let's find out what root system this our problem will present. So since we said we should let y equal to our x exponent m, we differentiate this to get our y prime. Y prime will be the differential of this. Remember simple differentiation rule. We drop the exponent, repeat the function, subtract 1 from the exponent. So the differential of this function will be this. Now we'll find the second derivative, which is y prime prime. That will be the differential of the first derivative. So again, we drop the exponent, m minus 1, repeat it and subtract 1 from the exponent. So m minus 1 will be n minus 2. Now we substitute the y, the first derivative and the second derivative into our differential equation. So we have our x square. In place of y prime prime, we substitute this. So that will be m minus 1, x exponent m minus 2, then plus 3x, our y prime is this, then m x exponent m minus 1, then plus 4, our y is s exponent m. So s exponent m all equal to 0. So now we multiply s squared by s exponent m minus 2, and that's indices. Indices is saying when the bases are the same and they are multiplying, we add the exponent. So we have s exponent 2 plus m minus 2. 2 minus 2 is 0, so we just have s exponent m there. So this times that will give us s exponent m, then times m minus 1, then plus 3. Now this is s exponent 1 times this, so we have s exponent 1 plus m minus 1, and 1 minus 1 is 0, so we just have s exponent m there. So we have s exponent m, then times our m, plus 4 s exponent m equal to 0. Now you can see s exponent m common to all, so we factor it out. So we have s exponent m out, m times m minus 1 plus 3 times our m, then plus 4 equal to 0. On divide both sides by s exponent m, then we have m minus 1 plus 3m plus 4 equal to 0, since 0 divided by any number is 0. So we can factor this, or can expand that. So we have m squared minus m plus 3m plus 4 equal to 0. So I'll have m squared, negative m plus 3m will be plus 2m, then plus 4 equal to 0. So this becomes a quadratic equation, so we need to solve this. So factors of 4, when we add, we get positive 2. We multiply, we get positive 4. There is no such factors. So we either solve this quadratic equation by completing a square or by the quadratic formula. So I want to use the quadratic formula to solve this. So I can say my m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where my a is the coefficient of the m squared, which is 1, and my b is the coefficient of the linear term here, which is 2, and the c is the constant, which is 4. So I'll just substitute into it. Then I'll say my m is equal to negative 2, since b is 2, plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is 4, over 2 times 1. So m will be equal to negative 2 plus or minus the square root of 2 squared is 4, minus 4 times 4 is 16, so minus 16 all over 2. So m will be equal to negative 2 plus or minus the square root of 4 minus 16, that will be negative 12 all over 2. So we can rewrite this as m equal to negative 2 plus or minus the square root of 4 times 3, then times the square root of negative 1. So when we multiply this, the square root of 4 times the square root of 3 times the square root of negative 1, we'll still get the square root of negative 12 all over 2. So this will be equal to negative 2 plus or minus the square root of 4 is 2, so 2. 3 is not a perfect square, so 3. And the square root of negative 1 will be I. I hope you get that. All over 2. So this will be negative 2 divided by 2 will be negative 1. Then plus or minus, this 2 divided by 2 will be 1. So we'll just have root 3i. So you have realized that m is equal to negative 1 plus or minus the square root of 3i. And so this is a complex root system. And remember, we said if m is a complex root system, then our general solution y of x will be equal to x exponent alpha times cos beta ln x, then plus I sine beta ln x, where our alpha is a real part of the complex root system. So we can say our alpha here is -1. And our beta is a coefficient of the complex system. So the coefficient of the complex system there is √3. I hope you get that. So our general solution there for y of x will be equal to x exponent -1 bracket cos into bracket beta, which is √3 ln x, then plus I sine √3 ln x. I hope you get it. We can repolish this and say our y of x is equal to x exponent -1 is the same as 1 over x bracket cos √3 ln x, then plus I sine √3 ln x. I hope you get that. Please, if this interests you, then like, comment, and subscribe to my YouTube channel if today is your first time of watching this video.